Good morning, guys. I hope you all are good and doing well for the preparation of your CAIs. Guys, this is the continuity of the first lesson we made for the vectors, and now we are going to discuss about the topic multiplication of vectors. Multiplication of two or more vectors. Guys, you need to know there are two methods to multiply the vector. One is called scalar product or scalar multiplication, and other is called vector product. Another name of scalar product is, we call this dot product. The word product or multiplication is same. Don't confuse this product, multiply. So scalar product is called dot products and vector product is called cross product. And you can define this thing when two vectors, because you are doing the multiplication of vectors only. So if you want to get the definition, when two vectors are multiplied such that their result or resultant is a scalar quantity, then such multiplication is called scalar multiplication. Scalar product or multiplication. You can take this example because science lovers know is better. Any work done is a scalar quantity and it is a product of displacement times force times displacement, you can say, or displacement and force is the same thing, but force times displacement. Force is a vector quantity, displacement is a vector quantity. So when you multiply these two vector quantities, the result is a scalar quantity. So this is the best example for the scalar product. There are a lot of others. Now if you talk about the cross product, but keep in mind that you are going to multiply vectors only. So cross product is that is when you multiply two vectors in a way their resultant in the same thing you need to carry on when two vectors are multiplied such that their resultant is a, here instead of scalar quantity if it is vector quantity, so such multiplication is called vector product or cross product. So only in place of vector here, scalar quantities, you will get the vector quantity. I will give you the example over here only. uh, for cross product, that means vector product, we can take the example of a torque. F times L, the moment arm. Torque is a vector quantity. The force times the moment arm is the directed distance from the line of action to the pivot point. You know that is directed distance. So it is a vector quantity as well. This is a vector quantity, and result is a vector quantity. This is the best example of a cross product. The cross product for the A levels has been almost removed, but few concepts we will discuss over here. Only we will prefer to move with the scalar product, that means dot product, because cross product is no more the part of our syllabus. Okay, now we will do the dot product. Suppose if take example dot product of two vectors. uh, Suppose we have two vectors. One vector is A moving in this direction, other is B moving in this direction, and the angle formed between these two vectors is theta. Right? They can move in any direction. So suppose the angle is theta. Then the dot product says vector A dot vector B will equal to the dot product of this one will be modulus of vector A times modulus of vector B times cos of theta. Cos of theta. This is the formula or the rule. You can say this is the rule which help us to find the dot product or scalar multiplication of two vectors. And sometime we need to find the angle when the vectors are when vectors are multiplying in a scalar product, like we can say cos theta from the here. Cos theta can be vector A, the dot product of two vectors divided by their respective modulus, and this will help us to find the angle theta. But what to do when they are cross multiply? Cross multiply is about the case what I talked to you that has been discarded from the syllabus. Uh, two vectors time there is angles with sine theta, but we are not going to discuss only. This is once when two vectors are parallel. Product of two vectors. Number one, we can say and we already know this, when two vectors are parallel, then we had a formula that two vectors A is equal to scalar multiple of, that is lambda, of other vector. And we in the first lesson we have done and we have discussed this, when what happens when two vectors are parallel and how can we find the value of lambda. In the first video we have done this. Here I will tell you, when two vectors are perpendicular, then what to do? We can say two vectors are perpendicular, then their dot product of two vectors should equal to 0. Reason, any two vectors are perpendicular, like suppose I can give you the example, vector A is here and vector B is going to this way, and the angle, they are perpendicular, so angle is 90 degree, and we know cos 90 is what, 0. So therefore you can use the formula A vector dot B vector is equal to modulus of A modulus of B cos of 90 degree, because cos 90 is 0, so this right hand side whole becomes 0, so vector dot product or scalar product for the perpendicular vectors always results 0. I hope it is clear, and we will solve few examples to help us to find the resultant. Okay, and say we have example like past example, given two vectors a having 1 2 p coordinate points, and vector b is having 3 minus 1 say 2, and vector a is perpendicular to vector b. Find if this find value of p. So what to do, as the two vectors are perpendicular, it is given in the question. Here I'm going to circle this thing. Yeah. This is perpendicular, this is the symbol of perpendicular, so they are perpendicular to each other. So what to do, we know, here I will solve this. When two vectors are perpendicular, then the dot product of that should be 0. So here 1 2 p and 3 minus 2 minus 1 sorry and 2 equal to 0, the dot product. In the dot product we will do multiply only the components. 3 times 1 is 3 plus let me write 3 times 1 plus 1 times 3, I'm going this way, unidirection. 2 times minus 1 plus p times 2 equal to 0. So 3 minus 2 plus 2p equal to 0. 1 plus 2p equal to 0. So 2p comes to be minus 1. So p is minus 1 by 2. That is the answer. I hope it is clear. And in this way, we can find when two vectors are what? If they are, you can say perpendicular, then their dot product should be 0. I hope it is clear. Now guys, we will discuss about the equation of a line. Starting from here, say equation of a line. In vectors, we have three methods to represent the equation of a line. Number one, that is vector form. Number two, that we call is parametric form. And number three, that is Cartesian form. Coordinate form. Three approaches to find the equation of a line in vectors. And first of all, we will discuss uh, the first case in vector form, and then we will find to how to convert vector form into parametric form, and then parametric to Cartesian form. So here, case 1, equation of a line in vector form, that is generally written as R equal to A plus say lambda m. And what is m? In few books we can write m. It can be anything. It can be as a vector b, but whatever be here, let me select this one, and m is called direction vector. As you know, in the coordinate geometry, we know this. We have equation of line like the same as y equal to mx plus c plus mx. So here m was a gradient, we can say gradient of line, this m, gradient of line is always equal to the direction vector. Your gradient tells us a direction, right? Position of the vector. So this is few information. Okay, we will discuss only from here. We will take from r is equal to a plus lambda m, suppose, where this is a vector form, and m represent direction vector. Here you can say here m represent direction vector, because it tells us about the direction of line, about the direction of line. That's why we call this direction vector. I hope it is clear, you are getting it. Next one, a. What a stand for? A is a point on a line. Any point on the line. As you have done 1 point and gradient formula in coordinate geometry, same, that point that exists on the line is a. And what lambda here Greek letter stand for? We call this parameters of the equation. That can vary, right? It will not be fixed. Parameter of the equation is called lambda here. And r represent the coordinates of, you know, in 3D we call it, say, x, y and z, right? In 3 dimension we are representing r with this, that are the variables of the line. Okay, suppose we have, for a particular case, we will solve from here we will say conversion of vector form to parametric form. And guys, don't be confused about this Greek letter lambda. In few books, sometimes it is written as mu, sometimes it's t, and it doesn't affect. So, but stay with that as the parameters of the equation. And instead of r, we can say any other, say a, b, c. You can take any variable or alphabet. You can use it. Any alphabet you can use in place of these. So generally, commonly, the values are using what I wrote it here. So here the conversion of vector form to parametric form. Vector form to parametric form. And for this case, let you have equation of vector form, line in vector form. We can write equation of line in vector form. Equation of line vector form is r equal to a plus lambda m or mu, whatever you want to write. Suppose this, let r having coordinates say any x, y, z, and a point, say point, we can say any point A is, we can say it's PQR, the point on the line with the direction vector any m. Direction vectors we can say STU. Then we will have this form. In place of r, we get x, y, and z. Point is p, q, and r, plus parameters we will write as it is lambda or mu, whatever you want to write, and it's s, t, and u. Okay, first we will start write it, keep writing x, y, z point as it is. Add these two, we get p plus lambda s, q plus lambda t, r plus lambda u. Right, so here we can say we are equating the coordinates. X will equal to p plus lambda s, and y will equal to q plus lambda t, and z is equal to r plus lambda u. So we can say these are the parametric equations in which lambda, is a parameter, is lambda, that is sitting between the x, y, and z. So we can say therefore parametric form of line that is x equal to p plus lambda s, y equal to q plus lambda t, and z is equal to r plus lambda u. So this set is called parametric form of the line. I hope it is clear. Now guys, now we will convert the equation of line in parametric form to Cartesian form. As the parametric form we have from the vector form, we have derived the parametric form as of line is x is equal to p plus lambda s, right? PQR, I told you that is the point on the line, and STU are the any, here you can see, let me, this one, sorry, I can write like this. Not doing well. Okay, it will be like this. And let me write it correctly for you. 1 minute. P plus it was plus lambda s and q plus lambda t and r plus lambda u. So I will p this. Here I can see this is the point, representing point, and this is representing direction vector. I will write direction vector, and xyz are the coordinates of the line. Okay, here I'm going to write the same over here, p plus lambda p this one, and then y equal to, that was q plus lambda t, z is equal to r plus lambda u, because the value of p q r s t u will be given to you, or lambda as well, parameters. So to find the exact value of the equation of line, so in order to convert this parametric form to Cartesian form, we need to find the value of lambda in either of the cases. 1 2 3 equation, we will find lambda. Make lambda as a subject in all equation 1 2 and 3. We will get as, what will get, if you make lambda as a subject from the one, it will be lambda is equal to x minus p by s, and from 2 lambda will be y minus q by t, and from the final third one we get lambda is z minus r by u. So all values lambda, so we can equate them. X minus p by s equal to y minus q by t is equal to z minus r by u. This is the Cartesian form of the equation of line, which is Cartesian equation of a line. So I hope it is clear how we derived it from the vector form to the parametric form and then the Cartesian form. Now finally we'll do a question to practice on this work. Okay guys, here's a question. Given that a line having parameters lambda and passes through point OA and OB, direction position vector of A and B with coordinates given, find the equation of line in vector form, parametric form and Cartesian form. So the first one, if you want to solve this in vector form, we know r is equal to a plus lambda m, as we have discussed. So this is the equation of line in vector form. So here first we need to find the point. We have 2 point O and OB. Suppose, and M position vector. Suppose we have uh, A coordinates here, A here and B here, right? So the position vector of AB, if we start from A to B, say AB is OB minus OA, right? So we will say it will be this gives us the the direction vector M. This tells us M, direction of this vector from A to B, because here we are going from A to B. So either we can take it from B to A like this, but here a little difference you will see in that direction. So the negative of that, A to B or B to A, only minus difference will turn up. So we can say this is AB. Sorry, this is AB from A to B, and this is BA from B to A. So first get the direction vector, that is M. We suppose this is from A to B. L. OB is 3. I'm writing in vector column vector like this, minus OA 1, 3, 5. I will get M as 2, 4, and 6 by subtracting them. So a point, now we are behind a point. M we have calculated. What is A? Here the point I'm going to write in note that need to be considered. If you are taking direction vector M by A to B, then always use point A, that is in the formula, equal to any I can point A equal to the coordinates of A coordinates, right? But if you are taking direction in the opposite of it, any BA, then always use point any A equal take as B, because we always take it from the starting point, from where the line starts the direction. So you need to be very careful. Then here you are moving from A to B, take this as a point, small a, and but from B to A you will take this point as a small a, right? So as we are taking from A to B, so we will take the point here, the coordinates of A, that is 1, 3, and 5 is given here. 1, 3, and 5, we will take this starting point. Now just replace it in the formula. We get R equal to 1, 3, and 5 plus parameter, and M is 2, 4, and 6. So this is the equation of line, and if R the in 3 dimension, we can say it's X, Y, and Z, and here it will be 1 plus 2 lambda, 3 plus 4 lambda, and 5 plus 6 lambda, or this one. You can write both answer. That is the first form, vector form, right? This is the answer in vector form. I wrote it in column vector form, right? I hope it is clear. Now we need to change that into parametric form. For parametric form, we will proceed it into by comparison. For parametric form, from the result in vector form, we will just compare the each coordinate x is equal to 1 plus 2 lambda, then y equal to 3 plus 4 lambda, and z is equal to 5 plus 6 lambda. And now get values of lambda from each case, from here, and here, and we will equate that. Lambda will be x minus 1 by 2, or lambda will be y minus 3 by 4, or we have lambda equal to z minus 5 by 6. So finally we can say the parametric form is, we can say required parametric form is x minus 1 by 2 equal to y minus 3 by 4 z minus 5 by 6. I hope it is clear. Now the third case is about the Cartesian. Okay, number 3, Cartesian form. This is the from parametric to Cartesian we have we got it together. Parametric form is this, and this was the Cartesian. Number third case we are doing, sorry, Cartesian form is in term of x and y z, and this is the required Cartesian form, right? Parametric form, just we need to write in term of lambda, and that's here, and the Cartesian form is this. I hope it is clear. The point which you guys need to keep in mind, that is this, I wrote in form of a note. That is very much important point, that if you are taking the direction vector from a to b, then always we will take the first coordinate, the point on the line from a. But if you are taking the direction vector from b to a, yani ba, then the point on the line will be taken as a coordinate of b. That must be the starting point. I hope this is clear, and this is the end of the basic concept about how to find the line of line of equation of a line in vector form, in parametric form, and in Cartesian form. And inshallah, the next step we will carry on the few more work examples and the concepts what left in the vectors in the next video. And finally we will solve the past year papers to apply all these discussions in the questions. Allah Hafiz.